IP Multicast. IP Multicast provides the capability to transmit information to multiple devices in the network by efficiently utilizing bandwidth. Several video and audio applications use IP multicast as their method of communications. Additionally, some of the routing protocols covered earlier use multicast. These routing protocols include OSPF, EIGRP, and RIP version 2. Many other applications such as database, replication software, and emergency alert systems also use IP multicast. Traditionally, a multicast device communicates with a group of receives by using an associate layer 3 class D address. The lowest bit of the first byte of the Ethernet multicast differentiate addresses must be a 1, which allows the device to differentiate between multicast and unicast packets. Multicast has a mechanism that tells the network about what hosts are members of a specific group. This technique prevents unnecessary flooding. The Internet Multicast Protocol (IGMP) is the protocol used to prevent unnecessary flooding. IGMP version 2 is defined in RFC 2236 and IGMP version 3 is defined by 3376. The Cisco ASA can operate in two different multicast modes, IGMP stop mode and PIM sparse mode. IGMP stop mode. To join a specific multicast group, a host sends an IGMP report or joint message to the routing device. The routing device sends query messages to discover which devices are still associated to a specific group. The host sends a response to the router query if it wants to continue to be a member of the specific group. If the router does not receive a response, it prunes the group list. This minimizes unnecessary transmissions. The Cisco ASA can be configured as an IGMP proxy. When configured as an IGMP proxy, the Cisco ASA forwards only IGMP messages from the downstream hosts. Additionally, it can send multicast transmissions from upstream routers. It can also be configured to statically join a multicast group. PIM sparse mode. In IP multicast routing, the network must be able to assemble packet distribution trees that identify a unique forwarding path between the source and each subnet containing members of the multicast group. One of the key objectives in the creation of distribution trees is to allow at the least one copy of each packet to be forwarded to each branch of the tree. Several IP multicast protocols exist, but the most commonly used is protocol-independent multicast. There are two different flavors of PIM routing protocols. Dense mode. Routers running DM routing protocols are required to forward multicast traffic to each group by assembling distribution trees. They do so by flooding the entire network even if the receivers do not request such updates. Subsequently, they prune all the paths that do not have any receivers. Dense mode is not widely used or recommended. Sparse mode. The SM protocols require that each router participating in the PIM domain be explicitly configured with a rendezvous point which controls group membership and is initially the root of the distribution tree. SM/IP multicast routing protocols start with an empty distribution tree and add only devices that specifically request to join the distribution. Cisco ASA supports PIM-SM as the multicast routing protocol. It can use unicast routing information base or multicast capable RIB to route multicast packets. PIM-SM assembles unidirectional shared trees routed at a rendezvous point per multicast group. Additionally, it can create shortest path trees per each source. Configuring multicast routing. The multicast routing command enables IGMP on all interfaces by default. To disable IGMP on a specific internet, use the no IGMP subinterface command. The multicast routing command enables PIM on all interfaces by default. If configured globally, use the no PIM interface command to disable PIM on a specific interface, statically assigning an IGMP group. You can configure the Cisco ASA to statically join a specific multicast group. You can also accomplish this via the CLI by using the IGMP static group command in interface configuration mode. An example shows how to statically assign an IGMP group in the Cisco ASA. The statically configured group in interface Gigabit Ethernet 0/1. The IGMP static group command only adds the interface to the multicast group. This is different from the join group command. The join group command adds the configured interface to the outgoing interface list, also sending an IGMP report for the configured group via such interface. Limiting IGMP states. The IGMP state limit feature provides protections against DOS attacks when attackers use IGMP packets. You can use the IGMP limit command in interface configuration mode to limit the number of hosts allowed join the multicast group on a per interface basis. Example shows how to configure this feature. In example, the limit is set to 100 hosts. The maximum number of IGMP states allowed on an interface is 500 and it is the default value. IGMP query timeout. In the Cisco ASA, you can configure the timeout period before the Cisco ASA takes over as the multicast query router for the configured interface. The Cisco ASA waits for any query messages to be received on the configured interface. If a query message is not received within the timeout period, the Cisco ASA takes over as the multicast query routing device. To do this via the CLI, use the IGMP query timeout command in interface configuration mode. The range is from 60 to 300 seconds. The default is 255 seconds. Example shows how to configure this feature with the query timeout value of 100 seconds. Enabling PIM. PIM is enabled by default when multicast routing is enabled. PIM elects designated router, which is similar to the mechanisms in OSPF. Via the CLI, you can use the PIM DR-priority command. In interface configuration mode, to set the priority for which a router is elected as the DR. The following is the command syntax. The priority value can range from 1 to 4 billion and the default is 1. The highest value is the priority in the DR election process. The Cisco ASA sends PIM hello messages to the neighbor routers. To configure the frequency of PIM hello messages, use the PIM hello interval command in the interface configuration mode. The following is the command syntax. The number of seconds that the router waits before sending a hello message can vary from 1 to 30,600. The default is 30 seconds. In example, the PIM hello interval is set to 100 seconds, the DR priority to 5, and the PIM join can prone interval to 120 seconds. On interface Gigabit Ethernet 0/1. Configuring rendezvous point. Rendezvous points are used as temporary way to connect a multicast receiver to an existing shared multicast tree. RPs are required only when PIM stop mode is enabled. If using the CLI, you can use the PIM RP address command to configure the address of a PIM RP for a particular group. Example demonstrates how to configure a PIM RP for a particular group. In example, the PDA keyword indicates that the specified multicast groups operate in bidirectional mode. If the command is configured without these options, the specified groups operate in PIM sparse mode.